So it says nitric acid, which is an aqueous solution, plus potassium hydroxide, which is also an aqueous solution, produce potassium nitrate as an aqueous solution and water in its liquid physical state. So take a look. When we work with net ionic equations, we are not going to dissociate compounds that are different than aqueous solution, okay? We're going just to dissociate those that are aqueous. So in the case of water, water will remain the way it looks, okay? Exactly like that, without dissociation. So in the first step, what we do is going to be the dissociation. I'm sorry, wait. So this is the first example. And in the first part, what we do is the dissociation. Okay? We're going to be doing the dissociation of every aqueous substance. Okay? Remember this. So we're going to dissociate HNO3, KOH, KNO3. Okay? Those are going to be the dissociations that we're going to be making in this kind of exercise. So for the acid, remember this. If you don't remember, go back to in your notebook, check the last part about dissociation. To dissociate acids, I'm going to zoom in. Okay, take a look. So, as you can see here, to dissociate acids, okay, the acid is going to split into its cation and anion, okay? So, the cation is always H+, and the anion is going to be the remaining part of the acid. This is how you dissociate an acid. So, we're going to apply the same process in the net ionic equation. So, we have HNO3. Its dissociation will be hydrogen plus ions, and this part of the acid, that is the anion, that anion is NO3. NO3 is nitrate, and nitrate has a charge that is -1. You have to write not just the ion but also the charges, okay? Ions without charges are not ions. So we finish with the first compound. We continue with the second compound. We have KOH, okay? OH is going to be the anion. And this OH tells me that it's a base. So we look for the dissociation of a base, and you will see that the base will separate into its metallic part and the hydroxide part. So in the case of aluminum hydroxide, it splits into aluminum 3 plus ion and OH minus ion. So we're going to apply this same procedure in the net ionic equation. So here, you need to identify the cation and the anion. So in the acid, the cation is always the hydrogen, okay? And the anion is the remaining. So again, this is the cation and this is the anion. Okay, so you are going to do the same process in the part 2. Potassium is the metal, and so potassium is going to be the cation. So potassium is K plus ion, and this is combined with OH. OH is the anion, and OH is written as OH, and it has a charge of -1. when we finish, we're going to continue with the products. In the products, we have KNO3. K represents the cation because it's the metal, okay? So this cation, potassium, you're going to write it as K plus, and it is combined with the rest, okay? That is NO3. NO3 is nitrate ion, and you don't forget to write the charge. The charge is -1. Once you finish to dissociate each compound, then water, which is liquid, you're just going to write it the way it is. Okay, no need for dissociation of water. Remember, liquid, no dissociation required. Okay? Solid, no dissociation required. And gas, also no dissociation is required. Only those that are aqueous. Only those that are aqueous, okay? So, once you have all this, you continue with the second part. In the second part, we need to look for the spectator ion. So in the second part, what you do is you eliminate the spectator ions. Spectator ions are those ions. Spectator ions are ions, okay? Ions. That means they have a charge. So you will eliminate what you have in the right that is repeated in the left. So I'm going to copy and paste this equation again because I don't want to write it again. And I'm just going to compare whatever I have in the reactant against whatever I have in the product. Now here in this part, I really don't need anymore the parentheses, so I'm going to get rid of the parentheses. And I will just compare whatever I have in the right with in the left. Question, can I eliminate H plus ions? Do I have H plus ion in the product?
No.
No. You don't eliminate because it is not in the product. In the product you have hydrogen, but that is hydrogen combined, okay? And that is a liquid, okay? It's not H plus ion. It's different. Now, can we get rid of nitrate? Is it
Yes.
repeated in the two sides? Yes. So we eliminate nitrate. That is one of the spectator ions. Now, can we get rid of K? Can we get rid of K plus? Yes. K plus, delete it. And then in the last step, what we do is we write the net ionic equation. So you're just going to write whatever you didn't eliminate, okay? Just the remaining. H plus plus OH minus produce H2O liquid. And this is the equation, the net ionic equation already. As you can see, it's already balanced because it was balanced from the beginning. From this process, do you have a doubt? Okay, so remember that you need to participate. Okay, so let's work with the example number 2. It says 2 silver nitrate plus barium chloride produce 2 silver chloride solid plus barium nitrate aqueous. So the first part that I do is I identify everything that I can dissociate. I can dissociate only those that are aqueous. Okay? Like the first one, like the second one, and like the fourth one. Okay? Now, this is solid. In a double replacement reaction, how do we call to the compound that becomes solid after the reaction takes place? How do we call the compound that turns solid after the reaction takes place? Nobody?
Solution.
Can you repeat?
Solution.
Could you type it in the chat? Yes, it is a solution, but no, it's not. The solid particles that remain in the bottom of the solution, they are solid particles. Those solid particles are not soluble. And those solid particles, they have a specific name. Do you remember the name?
Reactant.
Could you repeat?
Reactant.
Could you type it? No, it's not reactant. Take a look. When in a solution, okay, you combine substances. Those substances that are being reduced in water are known as aqueous solution substances. So when you combine the substances, these two substances, this is what we know like a double replacement reaction. It is a double replacement reaction because the metals change the position of themselves, okay? And then you will have different products, okay? Now in the products, you're going to have substances that can be soluble in water or that they are not soluble in water. In the case of a solid particle, is like, for example, when you mixed sand with water, okay? If you mix sand with water, eventually the sand will be right there in the bottom, okay? Those parts, even if you mix it, if you stir it for like 2 hours, the sand will remain in the bottom. That is because sand is not soluble. When you have particles that are not soluble, means that you have what we know as a precipitate. Y el premio pasó para el baúl. Honestly, I gave one extra point in the other section for that answer. It is that precipitate. That precipitate means that it's not soluble, okay? Now, take a look. What we do here is we're going to dissociate each aqueous substance. So, in my first step, I will dissociate silver nitrate. In the second step, I will dissociate barium chloride. In the third step, I won't dissociate silver chloride because it's solid. And in the last step, what I will do is I will dissociate the barium nitrate. That is going to be the process that I will be doing in this exercise. Okay? So let's see. Silver nitrate. Take a look. This too is going to affect everything. So this gives me 2 silver ions. Silver ions have a charge of +1. And nitrate, you also have that 2 that multiplies the nitrate, so you're going to have 2 NO3. And the nitrates have the charge of -1. In the other side, you have barium chloride. You have barium, which is the metal, is the cation, and it has a charge of +2. Then you have the chlorine or the chloride ion. You have 2 chloride ions, and chloride ions have a charge -1. In the products, you don't dissociate silver chloride because it's solid, and barium nitrate in this case, it will be requiring the dissociation. So barium has a charge of +2 and it's combined with nitrate, which has a charge of -1. But take a look right here. Nitrate is the one in the parentheses. And this parenthesis is being multiplied times 2, okay? Which means that here you will have 2 nitrates. What you do after is you will get rid of the parentheses. So far, do you have a doubt?
No.
Okay, now that you get rid of the parentheses, you will compare what are the spectator ions. Can we get rid of Ag plus?
No.
No. Can we get rid of nitrate?
Yes.
Yes.
Yes, we can get rid of nitrate. We eliminate nitrate here with nitrate in the products. Can we get rid of barium?
Yes.
Yes, we can get rid of barium here and also there. Can we get rid of chlorine?
No.
No.
So the only step that remains is writing the net ionic equation, that is everything that you didn't eliminate. So this will be 2Aj plus 2 chloride ion produce 2 silver chloride as a solid. And this will be the net ionic equation of the double displacement reaction that I showed in the beginning. As you can see, it is already balanced. Do you have a doubt in the process? Now take a look. I sent you an image to the group as a reminder. It is a reminder from last year's topic, which is the oxidation number. Maybe I reviewed it this year. I honestly don't remember. I think I didn't. So take a look. We're going to review it just a few rules, okay? It's a topic that I'm seeing with 10th grade. So let's see the rules. The first rule says that all elements in their free state means that they're not combined, have oxidation number 0. That means pure elements are not combined, or the diatomic elements like hydrogen, oxygen, chlorine, nitrogen. Okay? All of them, when they're not combined, their oxidation number is 0. Hydrogen is +1 except when it's with a metal. When it's with a metal, it's going to be -1. Oxygen is -2 except in the peroxides where it is -1. And when it is combined with fluorine, then the charge is going to be +2. But that is just one very, very specific exception. Metals or metallic elements have positive oxidation number. In covalent compounds, the negative oxidation number is going to be assigned to the most electronegative atom. To know the most electronegative atom, you have to look at the table of the electronegativities. And then remember the oxidation number in a compound of all the elements in a compound is 0, and in a polyatomic ion is going to be equal to the charge of the ion. So take a look. Knowing this, I'm going to write one equation as an example, okay? Well, 3 substances, and you're going to indicate the oxidation state. For example, okay, for example, that equation over there. I'm combining gold with nickel 2 nitrate. And I wrote as a result that no reaction occurs. The reason is because in the activity series, gold is below nickel, so we cannot replace it. But take a look here. Gold. What will be the oxidation state for gold? Is gold pure or is it combined?
Pure.
It is pure,
Is
okay?
pure.
When it is pure means that the oxidation state is 0, okay? Now in this case, nickel is using a charge. I identify the charge because it's the 2 that is outside nitrate, because remember, the charges are opposite to the element that they belong, okay? So this nickel is actually nickel that is using 2 plus as a charge. In this case, the nickel ion is going to be Ni2 plus. Another example, very easy example. Take a look. The equation for water. The equation for water. Is hydrogen pure or is it combined? Is it pure or
It
is
is
it combined?
combined.
No, it's pure. Take a look. It's separated by a plus sign. So, in this case, the hydrogen is considered to be pure. When it's pure, the charge is 0. Is oxygen pure or is it combined?
Pure.
It is also pure. Okay? In the product, is the hydrogen combined?
Yes.
It is combined. So, the charge that it will be using, according to the rule, is plus 1. Oxygen, it is combined too, and according to the rules, the charge is going to be 2 minus. That is very important that you know it. Okay? That's why I review the oxidation number part. Now, I want you to apply everything that we learned today into the first 2 exercises. Okay? These 2 exercises are going to be classwork. You're going to start right now, and when you finish, I will publish the answer key in Google Classroom, and you will tell me, Miss, I don't understand why this is wrong, or Miss, I have everything correct. Okay? So I will publish the answer key so you can check the process that you did, because if there are mistakes, you can do the correction of the mistakes now. And the remaining 3 exercises are going to be homework. Okay? So based on what you do in the classroom, in the classwork, sorry, you can predict how is the homework going to be for you. Okay? So start working with those 2 exercises. When you finish, send them to me. Okay? Remember that I will publish the answer key in Google Classroom, but I will publish it right in the moment I have a few classworks in my WhatsApp. So write the exercises, because if the class is over, sorry for you. Or just take a screenshot. How many exercises did you do?